Okay, that's great. So I hope that the guys that are missing didn't left because it was too boring. But so first of all, I would like to ask you if it is possible from your side to have a feedback if you think that it is important to show you this stuff about downloading the DEM, if it is important to show you how to work with really quickly with them in QGIS, how to merge them and to export them, so that then you can use them to extract a basin in HMS. So if you think it is important, I am going to show you right now. It's a matter of 15 minutes, something like that. So due to the fact that usually the probably most important part of an hydrological analysis is the identification of the catchment. If you think that it is important, I can show you. So please, if you can give me a feedback. No feedback. Okay. So let's move on. So before we stopped, we had a question about, I hope you can hear me well. It's important merging of the data, please. Okay, that's great. So one feedback is enough from my side. Okay, so before we stopped, there was a question about the threshold dimension for the DEM that we could download from the Copernicus website. So let me share my screen so that we can go back. Sorry. So that we can go back on the Copernicus web page. So do you remember I show you how to download a DEM, or at least an area of interest of a portion, okay, of our area of interest of DTM. The question was, in case I have an area of interest that is bigger than 450,000 kilometers square, that was the threshold. What I told you was that we had to download multiple pieces of this area of interest and then work with them in a GIS environment. So during the break, I downloaded a couple of DEM more. So if you remember, I opened the one that I downloaded together with you in QGIS. I don't know if somebody of you was able to register to the Copernicus website and download some DEM, but I'm going to show you, and then you have the recordings to do back again in case. So I downloaded a few more raster layers, and I am going to, if I find them. Sorry, there was a microphone. I'm going to upload them in QGIS. So the first one that we downloaded was this one, raster Copernicus 30, and I downloaded two more. I am going to upload them in QGIS. Now, I don't want to overlap to what you did in QGIS, but I saw the presentation and I think you didn't talk about how to merge raster layers. So this is a really important matter for HMS. And so I'm going to show you how to do it. So in this case, we have 3 different DEM that are covering different areas. But all of them are overlapping more or less one to the other. Now, the source is always the same because it's the Copernicus 30 meter. and in QGIS I can merge them, okay, to create a single DEM that covers all these areas of interest that I have downloaded into 3 different pieces. To do that, once I have uploaded my raster layers, I need to go in raster. Sorry, there is a microphone. I need to go into the raster menu. Okay. Now, into the raster menus, I have a miscellaneous, it's called, miscellaneous options. And I have a tool that is called merge. So really easy. You can search for it here in the menu, or you can search it also in the processing toolbox if you're talking about it. But really easily, if you click on it, it will open a window in which the only things that you need to do is to select the input layers. So to select our raster files, our DEM, that we want to merge together. And to do that, we need really easily click on this 3 dots icon and select the raster files that we want to merge together. So if I click all of them, because I want to merge all of them and create a single one, okay, I select all of them, I click OK. Then, as always in QGIS, I don't know if Baynet show you, but there are a lot of different options that are not necessary. I want to run and see what happens if I try to merge all of them together. Okay, it's completed. Let's close this dialog window. Okay, you see what happened. It has created a new merge, is called raster layer, that is the merge of the 3 different layers that I added before. If you're asking why there are these black parts, is because the raster layers must always be rectangular, okay? Once you create a raster layer, it must be always rectangular. And so what happened is that where you didn't have any information about the elevation, sorry, I need to admit all the people, QGIS directly created an area in which it is called you have no data. So I merge these 3 DTM and create a single one that I can upload into my HMS project and use to extract a basin. Well, I have created it, but I didn't export it. Okay. In this case, QGIS created a temporal layer that is visible because you have this icon here that I can anyway export and save as a raster layer. To do that, you just have to right-click on your layer and select Export. So I don't know if you talk about how to export layers during your QGIS training, but it is the window that appears if you want to export a raster layer. It is really similar also to the window that it appears if you want to export a vector one. So what you have to select is the format. In this case, GeoTIFF is fine. The file name as usual. Okay, so for example, let's select a file name, right? And really carefully, you need to select a coordinate reference system. Now, I don't know if you remember what we were talking about before the break. If we go back to HMS, also HMS needs a coordinate reference system. In our case, what we did was to skip the step of the selection of the coordinate reference system because we selected, okay, the same reference system that this DEM has by default. Now, the reference system that the DEM has by default is the one that you have to select here. So is the one that you select to save for your raster layer. What's really, really important is the fact that okay, yeah, written here, is the fact that we selected a metric unit system, okay, in our HMS. And it means that also the coordinate reference system that you have to use must be in metric. Must has metric as coordinate reference system. So the coordinate reference system that you can use, okay, is not so much. So you cannot use, for example, the WGS84 because it's geographic. I know you talk a bit about the coordinate reference system during the QGIS training. What you can use for the HMS is the UTM coordinate reference system. So depending on the zone of your area of interest, of your raster layer, you have to save your raster layer into the UTM with the zone in which you are. So here we are in QGIS 84 UTM zone 36 north. And so I can save and select my coordinate reference system as the UTM zone 36 north. So I don't know how much you did during the QGIS training, but probably you can do something a bit more, you can talk a bit more in deep about this topic during the in-person trainings. But what I wanted to stress you is the fact that HMS must use a coordinate reference system that is metric, and the fact that if you want, and I will show you later on, to add to the map of HMS other layers, what is important is that this layer must have the same coordinate reference system. Okay, so I will stop here because it's a bit tricky, and I will ask if there are some questions. Then I can show you, if you like, how to clip really quickly a raster layer in QGIS, so that you have also this, let's say, shape. And then we can move on and go back to the exercise in HMS. So let me know if there are if there are some questions about in general also DEM downloading, DEM operation in QGIS and in HMS. Okay. So if there are no questions, I can move on, show you really quickly that there is the possibility how to extract raster data based on basin. Okay, Beir, thanks for the question. What you mean exactly with how to extract raster data based on basin? So I have an idea, and I will ask you if that's what you mean. So I mean, what you're meaning is, in case you already have more or less an idea of your basin, because maybe, I don't know, you are working on Google Earth, and you're looking at the satellite, and you were able, more or less, to draw the basin. And you want to download a raster layer, a raster data, DEM, that covers this basin. How to do it? Is this a question? Or, okay, that's great. Yes, that's a good question. Because, yes, what will happen is that during the hydrological study, as I was telling you, the HMS is, let's say, a software that is used in the advanced hydrological studies. Because a lot of time, mainly, during the preliminary stage, what you're going to do is just, for example, the precipitation analysis and the basin abstraction. So, as your colleague was asking, sometimes what happens is that maybe with the satellite you are able to extract more or less a basin, or maybe with other tools, easy tools, you were able to extract a basin. And for some cases, also just knowing the dimension of the basin that you have to study is enough. So this is exactly the same things that happen here, okay? For the study at Bara, we knew in advance, more or less, how was the basin, okay? And that's the reason why you see that this DEM is really accurate, is really clipped, and you will see later on the edges of the Atbara subbasin. It's because we already had an idea of the shape of the subbasin, and what we did was to work on QGIS, okay, to do an offset of the basin that we had. And what we did was to download, okay, a raster layer that was more or less, that covered more or less the dimension of the basin itself. So it was considered that it was rectangular because you have to download rectangular tiles. So it was something like this that covered the entire subbasin. And to select it, you can just go, as I was telling you here, on the map. So by looking at the satellite on one side, that can be Google Earth, can be QGIS, and looking at this map, okay, you can change, you can use, for example, the hybrid, okay, if it's easier to you to understand where we are. Or the, sorry. Okay, sorry. I was telling you, if you already know more or less where we are, and you know more or less the area of interest of your subbasin, of course, you will not be able to download the perfect DEM that will be exactly on the edges of the subbasin. So you will download something more, of course. Then you will work on QGIS, in which you will have something like this. Let's assume, so let me show you really quickly what could happen, what could be the idea. So let's do this example. We have this sub-basin, okay, that our colleague created with Google Earth by looking at the satellite. And we downloaded these big tiles of DEM that completely covers our sub-basin, but as you can see, there is also a lot of DEM that is not necessary for our analysis. So what we want to do is to clip our DEM on our sub-basin. And to do that, there is a tool that is called, if you go on raster menu, there is an extraction option. There is a tool called clip raster by mask layer. And as you can imagine, what we'll have is that QGIS will clip the DEM, the raster layer, on your shapefile basin. So let's do just an example. As input, we need, as you can imagine, the DEM and our sub-basin shapefile. We can run, and you see that what happened, let's switch off all these other, is that QGIS clipped the DEM only on our shapefile layer. So at the end of the day, what you will have is a DEM that covers your sub-basin. Why we do that? And why we usually select a DEM, an area of the DEM that is bigger, okay, than the sub-basin that we have draw manually. Because HMS will give you the possibility, as you can imagine, to extract a basin with a lot of detail, okay, that usually you cannot be able to appreciate just with a satellite image. And that's why we select usually a bigger DEM. We know the breakpoint, so where to close our sub-basin. And HMS, I will show you right now, will give you the possibility to extract really in detail the sub-basin. Okay, I will stop here and see if there are some questions, see if everything was clear, or if you want me to repeat or whatever, okay? Bear, in this case, of course, if it is possible to have a feedback from your side, if that's what you asked. Okay, that's great. Okay. We can proceed. So this was more or less what is usually necessary to do to work with the DEM, with the terrain data, so that you can prepare it for the HMS analysis. Because as you can imagine, you need, first of all, to download it, and second, to merge, so that you have a single DEM that covers the entire area of interest. In our case, I already shared with you, and we already uploaded a DEM that we know covers the entire area of interest. So we are in a position, okay, to ask HMS to extract our sub-basin. Now, there are a few steps that we need to do to extract our sub-basin, and we can go really quickly back to the presentation, and then we can do as the exercise. So first of all, here in the menu, there is this GIS option, this GIS menu. Here you will have all the tools that are needed to work in the extraction of the subbasin. So we have, and to work generally with the terrain data. So we have uploaded our terrain data, we have connected it with our basin model, and right now, if you have connected it, you see that there are a few options that are that you can click on, such as coordinate system, terrain reconditioning, pre-process sinks, process drainages, and import georeferenced element. So let's start looking at coordinate system. You see, the coordinate system, if you click on it, it will open a window in which you have the exact information about the coordinate system of your basin. That, if you remember, are the exact coordinate system of the raster layer. So you see, the coordinate reference system that we are using right now is the UTM zone 36 North. UTM, that is a metric coordinate reference system. And it is really important to be a metric, because if you want to extract a basin, generally in every GIS environment, your raster layer must be in metric. Well, this was the first option of the GIS menu. The second option is a terrain reconditioning. So we are not gonna see it now, but let's say that it will give you the possibility to modify manually a bit the DEM. For example, if you know that the streamline change and that the streamline that of your DEM is no more representative of the reality, you can manually change a bit the DEM. But what is really important is the pre-process sinks and the pre-process drainage. Why? Because, well, probably all of you have some background about hydrological modeling. To extract a basin automatically, what you have to do, starting from a DEM, is to fill, okay, all the sinks. And then, once you have filled the sinks, to pre-process the drainage. What I mean with fill the sinks, let's go back to the presentation. The filling sinks is essential to give to HMS the possibility to understand the drainage directions. Why? Because let's do an example. I have a lake, okay? The lake has a that is a lot lower than the surrounding area. So all the water that goes, that fall around this lake will go directly into the lake. So the drainage direction will go directly into the lake and stop it there. So if we do not fill this lake, HMS will not be able to understand that once the lake is full of water, the drainage will continue into another direction. It's a bit tricky, but let's say that in order to create the flow direction and the flow accumulation, So in order to create the stream network, we need to fill all the sinks that are present into the DEM. Okay, I'm stopping for a few seconds in case you have questions, because it's a bit tricky. Anyway, if you are doing it with QGIS, with Global Mapper, if you are used to it, in general, if you want to extract a basin automatically with some software, with some plugins, usually what you have to do after you have downloaded your DEM, you need to fill the sinks of the DEM. Okay, I don't see questions. Once your DEM is filled, so once the sinks are filled, what we have to do in HMS is to pre-process the drainage. How the pre-processing drainage works in HMS? Always remember that we have a DEM. The DEM is a raster layer, and the raster layer is an image composed by pixel. In each one of these pixels, you have a value of the elevation. So for each one of these pixels, HMS calculates the direction based on the adjacent pixel that has a lower elevation. So it is called a 8-point poor model. So if I have my pixel here in the middle, okay, I have 8 possible directions in which the water can flow depending on the terrain elevation data. So if we have this example, and we have in the middle an elevation of 67 meters above sea level, and all around I have 78, 72, 69, 56, and so on and so forth. What is the lower elevation in these 8 points that will give me the direction, the flow direction? It will be 44. Okay. Now HMS does this for each one of these cells. And at the end of the day, what it will give us is a stream network. Okay, so for each one of our cells, it will tell us the direction in which the water flows, depending on our terrain elevation. It is tricky, but if we go back to HMS, you will see, and you can do it because it's part of the exercise. It's really easy. HMS will do it automatically, and we can try to do it together. So we have seen the coordinate system of our basin. We have to pre-process the sinks first, and then pre-process the drainage. So let's pre-process the sinks. HMS will need some time to pre-process the sinks, and this time is dependent on the dimension of the DEM and the precision of the DEM, so the dimension of the pixels of the DEM. And you see in blue all the sinks that has been filled from HMS. After we have done the pre-processed sinks, we can perform, always in GIS menu, the pre-process drainage. So if you click on it, HMS will do it automatically. Okay, that's great. I'm going to show you what HMS created, and then I will stop and I will ask if you are able to follow the instruction. Now, if we right-click in the map, there is the possibility to select a map layer. So to see all the map layers that are present inside this map, that are visible on the map. And you see that here I have a few, these are all raster layers. I have a few layers that has been created, has been selected. So when we started and when we uploaded the terrain, the only thing that we had here was the terrain. So if I switch off all the other layer, this was exactly what we were looking at before we did the preprocessed sinks and the preprocessed drainage. Now, after the preprocessed sinks, what HMS created was first another DEM in which all the sinks have been filled. You cannot appreciate the difference, but it's just because we are in a large scale. And the second thing that HMS created is the location of the different sinks that has been filled. That was exactly what we were looking at. After we have done the preprocessed sinks, we did the flow direction. So during the flow direction, HMS created a raster layer for the flow direction. That is exactly, if we go back to the presentation, what you see here. And created a flow accumulation grid. What is the flow accumulation grid? The flow accumulation grid is a raster layer. Let me switch, zoom in a bit. Is a raster layer in which for each cell I have the number of the cells that are upstream of mine. So the dark blue pixels, okay, are the pixels that has a lot of cells, a lot of pixels upstream of that location. So at the end of the day, what I have here is the flow direction, okay? The flow accumulation is called. So the accumulation of all the locations that are upstream of my site. It's a bit tricky, but at the end of the day, what we are going to do is to transform and to use this raster layer to create the streamlines of our subbasin. Okay, let me zoom up and let me stop for a moment. It's a bit complex, but if you are going to do any, as I was telling you, any automatical analysis extraction of a subbasin, these are the steps that you need to follow in every software that you're going to use. That can be QGIS, that can be Global Mapper, whatever. If you're not selecting these steps, it means that or probably the software is going to do it automatically by himself. Okay. So are there any questions? Were you able to perform the pre-process sinks and the pre-process drainage, because now what we are going to do is to extract the identified stream, to select the breakpoint, so the point in which we want to close our subbasin, and to extract automatically the subbasin. I will give you like a couple of minutes. As always, please, if you have the possibility, give me some feedbacks or like some screenshot in the chat, so that I know that at least somebody of you was able to perform the pre-processing and the pre-process drainage. Okay, Marnat, that did a good job. Okay, also Manuel. That's great. Okay, now boring part is gone. I hope so. And we can move on with the more interesting part. Now, if you were able to perform the pre-process sinks and the pre-process drainage right now, if you click on GIS menu, you see that there is a new option that is available, that is identify streams. So, as you can imagine, starting what HMS does is starting from the flow accumulation, from the drainage that we have created, he will be able to identify the streams that runs onto our area of interest in our DEM. So if we click on it, you see that you have to select a value that is, it is called area to define streams in kilometers square. What is this value? If we go back here in the presentation, I don't have it here. Okay, let me just explain to you. What is this value? This value is a threshold value. So in this case, what HMS does, and what HMS will do if I select this 23603, is to create all the streamlines that has a basin that is bigger than 23,603 kilometers square. Let's do some examples so that you can better understand. And instead of 23603, that is selected by default and depends on the dimension of the DEM, we can select, for example, 20,000. Let's click OK. So what does HMS will do? It will create a lines, all the streamlines that are inside this terrain data, with a basin that is greater than, bigger than 20,000 kilometers square. That's great. Okay. Now, unfortunately, it is not visible so easily. So right-click, map layers, and let's switch off some of these raster layers that has been created. Okay. Now you see that here you have some lines that seems dots, but if you zoom in, it is visible that are, I hope it is visible, that are lines. And these lines are the identified streams by HMS that runs into our digital elevation model, into our terrain model. These streamlines are composed by all those drainage lines that has a basin that is bigger than the threshold we have selected. What does it mean? It means that if I consider, for example, the end of my streamline, theoretically speaking, this point here is at the end of a basin of 20,000 kilometers square. Okay? I hope it was clear. So what happens in case I change the threshold of the identified stream? Let's do, for example, a change. Of course, if you click back again to identify stream, you will have a message that says the identified streams based on the new threshold area will only be used for new delineation. So what will happen is that, let's say, it will delete the identified stream that you have here. I see Mohammed with his hand raised. Yes, Mohammed.
Yes, thank you very much. So can you hear me?
Yes, I can hear you.
Yeah, thank you very much for this one. And actually the training was very informative. Actually, I have one question regarding this point, regarding the definition of this threshold. So in my mind, just so what I have in my mind, so that this threshold is only for visualizing the subcatchment in the whole basin. So my question is like that. So do we have a criteria to select or to identify this threshold? For example, why it is not 20,000? Why it is not 10,000? Why it is not 100,000? So I mean, what are the criteria that fill this one? Yeah, specifically, because I'm asking this one because I remember that I was conducting a training session for SWAT, and one of the participants raised this one, and I checked up all the literature. I didn't find that a criteria for this threshold. But I said at that time, I think all this threshold is only for the visualization of the streams and the subcatchments. So my question is that maybe you know more. Is there any criteria to select this one?
الستيب الأخير ده شكله شبكة يتخلى الستيب الأخير شبكة وقف ما قدرت ألقى يعني بعد
So yeah, this is just my question. So did you get my question?
Sorry, Nicola,
Hello.
you are muted, Nicola.
Oh, sorry. I think I was not muted. Yes, sorry, Mohammed. I was saying that it was yes. Your question is really clear, and it's a really interesting question. I will try to answer right now, but you will see in a few minutes the real answer. How to select the threshold based on the information that we have. So you're right, Mohammed, for a certain point. So the threshold is used for the visualization. I don't know exactly how it works in SWOT, but here the point, and we are going to see it after that, is the fact that you can select a breakpoint, only a breakpoint that is on this streamline that has been identified. So what I mean is, first of all, if you are identifying, if you are using a threshold that is too big, what happens is something like this. Okay, let's continue. Instead of 20,000, let's do, for example, 100,000. I click OK. And you see that right now my streamline, my identified stream, is a lot smaller and a lot less detailed, with less tributaries and so on and so forth. Because, why, sorry? Because all that tributaries has a basin that is lower than 100,000 kilometers. Now, what I mean with that? I mean that, unfortunately, in HMS, I can select a location, the end of my basin that I want to identify only on this streamline. So if, for example, I want to stop my basin in this location that is upstream of my streamline, this is not good enough. This is not detailed enough to abstract the subbasin. And this is the first answer. Second answer is, so yes, is the visualization, but it's also used for the extraction of the basin. Second thing is, and I will show you later on, if we go back with an identify threshold that is a bit lower, of like 10,000, okay, and I will select, for example, it's called breakpoint, okay, here in HMS, as I was telling you. And I select a breakpoint that is the end of my subbasin that I want to extract. For example, in this location, at the end of the conjunction between multiple tributaries, what HMS will do is to create a catchment for each one of the different tributaries. So what will happen if we look at this example of these two tributaries is that HMS will create a catchment for this identified stream, another catchment for this other tributary, another catchment that stays, that starts at the end of these two tributaries until the arrival to the mainstream, and so on and so forth. So one catchment for each one of these streamlines, of these tributaries. Okay, so my answer to your question is, it depends on what you have to do. Because let's do an example. I want to do a model, and I am doing a study, a preliminary study. Okay, let's do with SWOT, so that it's related to your case. I'm doing a study. I want to do a study of the sediment transport for the Atbara basin, okay, or for just the final portion of the Atbara basin. That is exactly what we are going to create today. So today and tomorrow, the model of the final portion of the Atbara basin, the upstream section, the upstream catchment of the Atbara. Depending on the scale of your study, what you can do is to create a single catchment, okay? Or if you want to do things more precisely, you can divide this big catchment into multiple sub-catchment. So at the end of the day, depending on the study that you have to do, what you will have to choose as your threshold depends on if you want to create a single catchment or if you want to create multiple subcatchment. Let's do this example. So I move on and I'm showing you this example. Once we have selected our threshold and we have our identified stream, to extract the basin, okay, what we have to do is to select a breakpoint. So it is to select the end of our basin. Let's do an example. To select the breakpoint, you have to go always on GIS menu, select the breakpoint manager, and sorry, I was wrong. Here you can import if you have them. You have to select this icon, the breakpoint creation tool. And you have to go in the map, zoom in, because you need to be sure that you are going to select a cell that has been identified as a stream, and you select a breakpoint that is on your streamline. So really easily, you click on it, and you create a breakpoint. You can call it as you like. Let's keep it breakpoint 1. You create it, and you have a breakpoint. So starting from the identified stream and the breakpoint that is the end of the basin that you want to extract, HMS has all the information to extract the basin. Now, as I was telling you, in this case, I have a single streamline that start from the breakpoint that I have selected. So what HMS will do, it will create a basin, a model, okay, composed by a single catchment. So let's do this example. I have selected my breakpoint. I can go back in the GIS menu and I can ask HMS to delineate my elements. What I mean, if you remember, the elements of a basin are exactly what the basin is composed by. So the different subcatchments, the different reaches, the different junction. Sorry, I had a notification. So if I delineate my element, I have to select a prefix, because what HMS will do is to create these different elements. Sometimes you can have more than one, depending on the precision, and I will show you later on what I mean. So you can select a prefix for the subbasin. It's called subbasin, but we are talking about subcatchment. A prefix for the reach. You can select to insert junction automatically. Let's say yes, and let's call it J. And you can select to convert the breakpoint, that is the red dot that we have here, into the sink, into let's call it tank, okay? That is where the water will flow naturally. I know right now it's a bit tricky, but the more we will move into it, the more you will understand. But right now we are trying to answer to Mohammed. So if we delineate, what happens is that HMS will create, you can see it here, a single catchment. What does it mean? It means that if I am going to simulate what is happening in my area of interest by considering a single catchment, I will be less precise than dividing my catchment into multiple subcatchments. So it is difficult to answer you, Mohammed, because the real answer is it depends on what you have to do. It depends on the precision required, okay, from your client, from whomever, from the study. And depending on this precision, you have to identify streams, so to change your threshold, to use a single catchment, or to divide your catchment into multiple subcatchments. So let's move on with the example. We are in the example of Mohammed, in which we don't know exactly which threshold I want to use. I tried to use, I don't remember exactly, but it was like 10,000, I don't remember. And I have created a single catchment. But my study, the study that I have to do, the hydrological study that I have to do, is requiring me a more precise answer of the basin. So, for example, I need to know better what is happening upstream in this subcatchment, what is happening in this other subcatchment, and so on and so forth. So what I have to do is to change the threshold of the identified stream. If I want to increase the subcatchment, I need to reduce my threshold. Okay, so let's do an example. I don't remember what I was using before, but if I use instead of, I think I was using 10,000, I use just 2,000. I need to use more than 2,000. Let's use 500. Okay. You see that right now, my identified streamline is much more precise, because I'm telling HMS to give me all these streamlines that have a basin that is bigger than 500 kilometers square. While before I was asking HMS to give me all these streamlines with a basin that was bigger than 10,000 square kilometer. Okay, yeah, please repeat. I am going to stop in a few minutes. So right now, if I want to delineate back my elements, what we are expecting is that HMS will not create a single catchment anymore, but it will create a catchment for this streamline, a catchment for this tributary, a catchment for this other streamline, and for each one of our tributaries. Let's do the example. Before, we select the prefix and we delineate. Okay? You see that right now, my first catchment has been divided to multiple subcatchments. Each one is characteristic of a tributary. Okay, so Mohammed, I don't know if I've been able to answer you, but you know, unfortunately, it really depends on the kind of study that you have to do. Okay. So, for example, in this case, we already have some I don't know how to call it exactly, but we had these 4 subbasins, and we also have the first division into catchments. Okay, I don't remember exactly the numbers, but we were talking about like 5 to 10 catchments per subbasins. So we had some indications about the dimension of the different catchments that we had to create. And so we had the indication of the precision that we needed to obtain during this analysis.
Yeah, thank you very much.
You're welcome.
Yeah.
Okay, so it was clear. Okay, I have Marnat that is asking to repeat. Error. Okay. Marnat, please, what you're talking about with the repeat, which I also have Ryan that was able to extract the basin. Marnat, if you can tell me what you want to repeat. In the meantime, I am trying to resolve the problem of Tadele. This is a common error while you are trying to extract a basin. What does is telling you? It's telling you that the breakpoint 1 is not intersecting an identified stream. Okay, that's great. So why it is happening? It is happening because your breakpoint, you have to zoom in a lot. Your breakpoint was probably like this. So it was outside, it was not on a pixel that has been identified as a streamline. You see, this is a green pixel and not a white that is where the streamline was identified. So what you have to do is to zoom in and move your breakpoint. Now here I see that you have more than a single breakpoint. Probably you click 2 times. Can happen also in this case. So probably you are like selecting and creating your breakpoint, and you click 2 times. And you created a second breakpoint. You did something like this. So what it's telling you is that maybe one breakpoint is on a streamline and the other one is not on a streamline. So what we have to do is to delete the breakpoint that you're not going to use it. And to do that, you have to go on GIS, Breakpoint Manager, and you see that here you have all the breakpoint that you have created. And you just have to select the one that you want to delete. In this case, the breakpoint 2 that is not intersecting the streamline. Delete. You delete, and that's all. So try again. I hope it was clear. Okay, that's great. Marnat, repeat the process starting from the breakpoint. Okay. Let me delete the breakpoint that I have created. So we are in this situation. Don't look at the catchment that has already been created. We are in the situation in which you have, if we open the GIS menu, we have pre-processed the sinks, we have pre-processed the drainage, and we had selected a threshold to identify the streamlines. So in our map, we have the DEM, if you have switched off all the other raster layer, and you have your streamline. You can zoom in and you can better watch at the streamline. Now, what you have to do to extract the basin is to select a breakpoint, it's called. The breakpoint is the end of the basin, the location in which that is the end of the basin that you want to extract. So let's do another example. I want to select a breakpoint that is at the end of my subbasin. So this is the Atbara DEM. So for example, I want to extract the subbasin of the Atbara. Now I don't remember exactly the location in which we closed the Atbara. We had it, but I didn't have it here, so I cannot select the exact location, but it was something like this. So at the end of the subbasin, at the end of the drainage lines. So you have to select the breakpoint creation tool, Once you have clicked on it, you go back on the map, and you see that right now the cursor is changed. And you have to select a pixel that is intersecting the streamline. You click on it, and you create the new breakpoint. Okay, now we have identified the stream, we have the breakpoint. What we have to do is to ask HMS by clicking on GIS menu here to delineate the elements that compose my subbasin, the Atbara subbasin. So we select the prefix. You can select what you like. I mean, you can use prefix for the subbasin like C instead of subbasin. We can use the C for the catchment. Instead of reach prefix, we can use S for the streams, and so on and so forth. We click on delineate. Every time you change, it will ask you, it will tell you, careful, if you have already identified some element and you want to do it back again, what will happen is that I'm going to delete the existing one and create new ones. In this case, I can continue. And you see, this is what will happen. So in this case, I have the different catchments. Okay, it's not the one that we used. Different catchment created by default by HMS that all together create the Atbara subbasin. Okay. So Marnat, let me know if it was clear.
Yeah, thank you. I got it.
That's great. Okay. If there are no other questions, I'm gonna wait a few seconds. But if there are no other questions right now, so we have seen how to extract a basin, but we are in the position of, you could ask me, like, okay, but how do I know where I want to put my breakpoint? Where I want to close my subbasin? So the location that we need to select for our subbasin. It's always related to the question of Mohammed. Not really, but I mean, we have seen, maybe we have many subbasin, yes. What do you mean with many subbasin? Probably what is meaning is that if you see here, depending on threshold that you have used, there are a lot of different subcatchments, let's call them, because subbasin is like the entire Atbara. There are a lot of different subcatchments that has two problems. First one, maybe there are too many. So what we have to do is to go back to the threshold of the identified stream and change it. Second one is the subcatchment that has been created, the catchment that has been created are not the one, for example, that we used for the models. Because if we go back to the presentation, you see this is exactly the Atbara, but you see that the catchments are different. Okay. So the possible question I think that could be is that, yeah, but if we have a determined location in which we have to create the catchment of the subbasin, how do we have to do it? The answer is simple. We have to use more than a single breakpoint. Because, for example, let's try. I don't know if it works right now. But if we want to divide this big, it's called C9 catchment, into multiple sub-catchments, what we can try to do is to add another breakpoint. Okay. So I have my streamline here, and let's make the case that this is a point in which I need to create another breakpoint. Let's try to delineate back again my elements. Let's see if it works. Sometimes it does not. So, okay, yes, it works. So you see that, for example, right now, I have inserted a breakpoint here that could be the location of a dam. Okay. And what does HMS did? It splitted the big catchment into two different ones. Okay, I don't know if it was clear. Let me see. Here we have Ryan, okay, with a lot of subbasins. Okay, so with the threshold of the identified stream that is really small. But I think that, okay, we are more or less all on the same page. Now, as I was telling you, a possible question will be, okay, but how do I select my location? It's always a combination between HMS and GIS. Because, for example, if we go back to QGIS here, probably I'm gonna show you something that you didn't do in the training, but it's just to let you understand what I'm meaning. I'm adding a satellite image, okay, really easily. Inside the training folder, it is not this one. Inside the training folder, sorry, but I closed during the break. Okay, here we are. In the GIS folder, there are two different folders. The first one is the raster folder, in which there is the DEM that we are using right now. In the second one, called the shapefile, you have the reservoir location of the Atbara, and in particular, the Tekeze. Now, if we upload these shapefiles in QGIS, you see that, let me change a bit the symbology. The green square are all the location of the different dams. For example, here, you see, it's not perfectly on the dam, but it's not a problem. So what I mean is, let's do the example in which we want to create a sub-basin divided into catchments that ends with a single breakpoint for each one of the dam location of the reservoir. So what we can do is to add and to select this location as a breakpoint in HMS. To make it simple, I have selected in red a single point in which we want to close our model. That is exactly at the end of our basin. So it is really easy to see it on QGIS. It is a bit more difficult to see it in HMS, because in QGIS I have the possibility to add a satellite image. In HMS, I do not. So what I usually do, and what you can usually do, is to create a vector layer, a point vector layer, in QGIS or Google Earth or whatever you usually use, ArcGIS, and to export it on the same coordinate reference system that you are using in HMS, and upload this shapefile in HMS. So you will not be able to see the satellite image in HMS, but you will be able to see the location that you have selected in QGIS with a satellite image. So you can use that shapefile as a reference location in which you can put your breakpoint. How to upload a shapefile in HMS? To upload a shapefile in HMS, you have to go back with the right click in the map, in the map layers. Here, now that I have created all these identified stream, all these subcatchment, all these reaches, I have a lot more layers than I had before. For example, I have the layer of the breakpoints, I have the layer of the subbasins that are the catchments, the layer of the reaches, the layer of the icon. The icon are, sorry, I didn't explain you, but for each one of the catchment, for each one of the reaches, for each one of the junction, you have an icon. This icon is representative of the element that you have created. So as you can see, and as you can imagine, the icon for the subcatchment is different than the icon of the reaches. So the icon of the subcatchment is this one. The icon of the reaches is the one with the R as a prefix. I don't know if you can see it really well on my screen because it's a bit small. The letters are not so big, but I think you have it also on your screen. And so on and so forth. It's a different icon for the junction, it's a different icon for the sinks. So what I wanted to do right now is to add, in the map layers menu, the shapefile of my Takedze location. So the shapefile in which I want to create the breakpoint, in which I want to put my breakpoint for the creation of the Takedze catchment. That is exactly, okay, the one that has been used here to create the subcatchment that is called AT Takedze. Now to add a shapefile, you have to click on Add, okay? So that is like add a map to the draw order. And you have to select your shapefile. In this case, I go into shapefile folder and I select the Takedze shapefile. You can import both the Takedze, both the reservoir, so that you can see what happened. But okay, right now you see that once I have uploaded it, I have a new takedze.shapefile. It's not easy to understand. I see it on my screen. It's this small blue square here. But I can, if I want to make it more visible, I can draw the properties, so change the symbology of my layer. So by selecting it, you have the possibility to select draw properties. And here you can change both the style, the color, and the size. So let's change, for example, the color, because the dark blue is not that visible. Let's select something else, this pink color, and let's increase also the size to 10. Let's try. Okay. Now you see that is a lot more visible. So this can be used as a reference to select the location for my breakpoint, because if I zoom in, I see that I have a reference right now. So what I can do is to delete my existing breakpoint and put a breakpoint the closest possible to my pink square, but carefully, it must always be intersecting the identified stream. Okay? So I hope it was clear. So right now I have the breakpoint for the creation of the HEC catchment. That is the one that we are going to use tomorrow for the simulation run. And what I have to do, what is missing, is just to redelineate again the elements. Okay. So this is exactly the catchment that we used during the project to characterize the Atbara subbasin. Of course, it was just a catchment of the Atbara subbasin. It's the upstream. So I'm going to stop for a few seconds, few minutes. Let me know if you were able to follow the instruction. And in case you have any questions, let me know. Okay, see no questions. If it is possible, share a screen of the Takeze catchment created, so that I know that we are all on the same page and we can move on. I don't see yet any feedbacks, but I hope that you were able to follow. So while we are waiting, I'm just recap what we did. We have 20 minutes left, but what I wanted to stress today at least was about the creation and the extraction of the basin. maybe I can show you also another useful tool that is external to HMS. But I want to stress also the fact that if you remember what we did before, here we were looking at the satellite and at the DEM that we have downloaded and merged together to create an example subbasin. Well, as you can imagine, if we look at HMS, what HMS did is a subbasin, a catchment that is much more precise, talking about, of course, the edges of the catchment, okay? It is much more precise than what you can do manually. So this is what you can do to create, to extract a basin in HMS. Of course, there are other possibilities for the GIS menu, because a simple question that you can do me is, okay, but once I have created my basin, that I can use it also for other purpose, for other analysis, external to HMS, I would like, for example, to export these subbasins. I would like to export this identified stream that can be used also, for example, in QGIS to characterize the drainage of an area. How to do it? In the GIS menu, there is this option called Export Layers. And here you can select what type of layer you want to export. So you can export, for example, the subbasin. You can export, for example, the breakpoints or the identified stream. Just to give you an idea, let's do an example. If I want to export the subbasin and the identified stream, I can save it directly in the shapefile folder. That gets the catchment. Okay, and I want to export also the identified stream. In this case, the identified stream is the identified stream of the Atbara. Okay, I have exported them. And if I want to, for example, upload them in QGIS, in a GIS environment in general, if I go back here in the shapefile folder, I have my Atbara streams layer and my Takkeze catchment layer. So I don't know if and how during your QGIS training you were used to upload a shapefile into QGIS, but you can really easily select the .shapefile and drag into the QGIS project. And you see that here I have my Takkeze subcatchment and my Atbara, if I change a bit the style, my Atbara streamlines. Okay, this is really, really useful. Of course, also in this case, this is really important if you have to do something that is a bit more detailed than what you are used to do, for example, in case you are drawing your catchment manually. But if you like, I can show you also an external tool that can give you the the opportunity, okay, to extract a sub-basin that is a lot less detailed than the one that you can extract with HMS, but is much more faster. Now remember that here we are extracting a basin that then, of course, we are going to use for the creation of the model and for the running of the simulation. But this procedure can be done also in case of a different study in which I need to extract and export a basin of my area of interest, extract and export my drainage lines of the of an area of interest. And I wanted to do it. Really precisely. I can use HMS. I could stop here, export my basin, my identified stream, and use them, for example, in the creation of the map in the QGIS. That is something that you have seen during the QGIS training. Okay, so I will stop here a few moments. Let me know, please, if you have any questions. Give me some feedback, some screenshots, and let me know, please, if you want me to show you also this other external plugin, online plugin, that gives you the possibility to extract and export, yes, a less precise catchment, but in a way that is much more faster. I have a hand raised by Maybior.
Yeah, thank you, Doctor. On a very simple question. On my screen here, I don't have chat option whereby I can access. So I don't know to access maybe the form. I see there is a form there to be filled. That's my question. What can I do?
I don't know if I catch your question. I think that you're asking about the form because you cannot access the chat in Teams.
Yes, correct. That's it.
Okay. So I think you have more or less something like a screen that is similar to the one that you are looking here, correct?
Okay.
You're using a laptop, not a mobile.
Yes, I'm using laptop. Yeah.
Okay. So here in the top, you have a few options. You have a chat. I think now I have it in Italian, but it's like chat, members, hand. So if you click on chat, what will happen is that in the right side of your screen, it will open the chat of the meeting.
But I think my screen here is starting with people, which are the members. Then you go to maybe raise.
You don't have
React.
chat.
I don't have chat.
Maybe other.
I don't know. Maybe here we have raise, React, view. Then it's giving me more option, but it's not there also.
So you don't have the chat.
Yeah.
Okay, so maybe what we can do is to send an email to all the participants to fill the form.
All right.
Okay, let me copy and paste. Or I don't know, Mumna, maybe you can do it directly. Let me know. If you're there. I don't have Muna. Okay, so maybe I will try to send the link on with an email after we close the meeting. I would like to know from your side, guys, if you wanna to let me show you this other external plugin to extract the subcatchment, I can also just send you the link in the chat, or then of course for maybe or in by email. But please just let me know. Otherwise, we can move on with the presentation. But for today, I think my purpose was to extract the basin. I can show you a few things about the characteristic of the basin, but we will see it in detail tomorrow. And then tomorrow we will start, okay, with the, let's call it real creation of the model, with the estimation of the initial parameter and the creation of the other components that are necessary for the creation of the model. Okay, so the link to the chat is sorry, the link to the form is this one. I will really quickly share with you also this useful tool. I see Ryan. Okay. Super expert with QGIS. Now, this useful tool, I'm going to show you in a couple of sorry, I will need a couple of minutes just to show you, because it's really nice. It's not really related to HMS, but can be useful for what we were talking about when we were talking about the extraction of the DEM on a subbasin that we can draw manually by looking at the satellite image. We can draw manually by looking at the DEM, but there are a lot of different tools, such as this one, that gives you the possibility to not draw it manually, but anyway, giving you the opportunity to extract a basin that is much more precise than what you could do manually, less precise than what you can do with HMS, but it's really nice because it's really, really fast. So for example, you have a coordinate. Let me see if I have the coordinates here. No, unfortunately not. Yes, I have it here. Okay, let's make the case that I want to extract really quickly a subbasin at the catchment of the Takeze. I have this coordinate here of the Takeze. I don't have any time to do it with HMS because it's too long, and I don't need to do it so accurately. So I can use this external plugin called Global Watershed that gives me the possibility to define the subbasin in two really easy ways. The first one is to delineate the watershed upstream of a point that I click on the map really easily. So if you directly know the location, here you can change also the satellite. If you directly know the location, you can just click on the map and delineate the upstream watershed. Easy one. Instead of drawing it manually, you have it here directly. Another thing you can do, instead of clicking on the map, if maybe you have a precise coordinate, you can go on option, make the results downloadable, of course, and enter a coordinate. So you see, enter latitude and longitude. Okay, so if we have, for example, here our latitude and longitude, latitude is 13.339. Okay, comma, and longitude 38.7449. I click OK. And here we are. You see? It has selected me this light blue point that is exactly the one that I gave here. And what the tool does is to select the closer, okay, drainage point to that one that I gave him, and use it as breakpoint to select and create the catchment upstream. It's a lot. It's less detailed than the one that you can do with HMS, but as you can see, it's a lot more easy because here you don't have to pre-process the sinks, you don't have to pre-process the drainage, you just have to select the location of your breakpoint. Once you have done it, what you can do is to download, for example, the watershed boundary as a shapefile. Let's try to upload it on QGIS. Sorry, I didn't zip it. And here, you see, I have in pink the catchment that I have extracted in HMS, and in red, the one that I have extracted in with this external tool. Now, the location of the breakpoint was a bit different, as you can see. But let's look at the edges of our catchments, and you can see that more or less we are following the same path, the same edges. Okay, so it's an external tool that is really, really useful. And you can use this one, for example, if you want to understand the dimension of the DEM that you have to extract from the Copernicus 30-meter. Okay, once you have this watershed here, you just have to select the area and then download the DEM. Okay, I hope it was interesting enough. So maybe I don't know if your hand is raised from before or not. But I would stop here, Muna. So what we are missing and what we are going to do tomorrow is, first of all, I'm going to show you, okay, see another hand raise. Tomorrow I'm going to show you the characteristic that HMS calculates for our elements, for our catchment and for our reaches. And then we will start to go deep into details on how to create the component of the model that we're missing, how to select the variables, the coefficient, and how to run the simulation. Once we have run the simulation, we will see how the change in the parameters changes also the results, and we will talk a bit about calibration and verification of the model. Okay, so Anbase, I think you have your hand raised. If you have any question.
No, this is not, I don't have any question. This is just, I want to make a small remark about the participant list. I see a lot more people on the chat or on the Zoom, but only few people have completed the form, and please complete the form before you leave the meeting.
Okay, that's great. So let's leave a few seconds in case you have any questions, in case you have anything else to say, and then I think we can close. Okay. So Moon, I don't know if you want to say a few things, but okay.
Yeah. Thank you, Nicola. I think it was very, very interesting training sessions, and it was very informative formation. So since there is no any hand raised, I think we can stop here today, and hopefully we will continue tomorrow at the same time with the same momentum. Thank you all. Thank you, our instructor, for your very, very good way to deliver the information. Thank you so much, and thank you all participants. See you tomorrow.
Thank you. Okay. See you tomorrow, same time.
Bye-bye, everybody.
Bye-bye. See you tomorrow. Bye.